Welcome back to the future. In this part of the lesson, we are going to learn to block on futures and how to control them with the promise pattern. Let's see what this is about. Now, why would we want to block on a future? Well, sometimes it makes sense to block on a future for critical operations like bank transfers or financial transactions or anything that is transaction-like, and you want to make sure that the operation is fully complete before you move on to display some results or to compute additional values. So let's design a small example for that. So let's imagine that we have a small online banking app with users and transactions. So if I have a case class called user with a name, I don't need anything more, and a case class called transaction, which has a sender and a receiver. So sender is a string, receiver is a string, and the amount, of course, makes it a double. And let's say that this transaction also holds some kind of status or something like that. Okay, so this is a truly minimal API for users and transactions. And if we have a small online shop or banking app, let's say called banking app, let's say we have a name for our app, which is Rock the JVM Banking or something like that. And let's add a small API on this banking app that a client application could use. So for example, we can have a future returning fetch user, much like we did for the social network. So if we have a name, which is a string, and this returns a future user, we can say future, and let's simulate a long computation or fetching from the database, which often takes a while, especially in distributed systems. We can say thread sleep. Let's let thread sleep. Let's say we sleep for half a second and just return a user with that name. Simple. Let's create a small method called create transaction from a user to a merchant name. So assuming that our banking app supports a number of merchants, we just pass in the merchant name here, and we are in charge of checking the merchant status or some other kind of auditing or checks, and we would create a future of transaction. And let's say we also pass in the amount, which is a double, and this would create a transaction, of course in a future, because we want to do asynchronous computation. So again, so simulate some processes like checking the merchant status. Is it a valid merchant? Is it a scam? Has it been flagged or something? Things like that. So we would say thread sleep. Let's say we sleep for another second, and we would create a transaction with user. This is the sender. Actually, it's user.name, and the merchant name, and the amount. And also let's pass in a status. Let's say success. All right, we can implement much more complicated logic here. In the case that a merchant is not valid or is a scam or something like that, we can deny the transaction. But for now, this should be enough, and we have a good structure here. So we have a future. Of course, I also need the future apply method here, and we should be good. And also, let's create a method called purchase, which allows the user to purchase something through our little banking app. So let's say we have a username, which is a string, which is passed in from our little client app, an item, which is a string, and a merchant name, which is a string, and the cost of the item, which is a double. And this would return the status of the transaction as a string. This is very important. So at the purchase level, we need to do the following. We need to fetch the user from the DB, and actually make sure that the user has enough money in their bank account and that kind of stuff. Create a transaction from the username to the merchant name, and then, very importantly, wait for the transaction to finish. Otherwise, I will not return anything here under the purchase status. So how are we going to do that? Well, this is a similar example to the social network case, because we are returning a future by fetching the user from the database, and based on that, we create a transaction which returns another future. And then we need to return that transaction status. So we can say val transaction status future equals 4, and we can do user left arrow fetch user by the username. So this returns a future with a user object, and given the user value inside, I can create a transaction. So let's say transaction left arrow create transaction from user to merchant name, and the amount will be the cost of the item. And given a transaction, I will yield transaction.status. Now, the way that we're going to block for the transaction status future is to say await.result, and we need to import the await class. So await.result, and we're going to pass in an awaitable, which in our case is a future. So we're going to pass in transaction status future and the duration. And watch what I'm about to write. I'm going to say 2.seconds. Now, at this point, you might be legitimately asking, Daniel, what the heck? There is no .seconds method on the in class. But watch what I'm about to write. I'm going to go to the top and I'm going to say import Scala concurrent duration underscore. And this automatically fixes the problem. So this is as if the .seconds method was somehow by magic added to the in class. Now, you might be still legitimately asking, Daniel, how the heck is this possible? And I'm going to say that this is possible through implicit conversions and a technique called pimp my library. We are going to dive really in depth in the implicits chapter, but for now, just assume that the 2.seconds method returns a duration object which is suitable for the result method on await. Now, if in the main piece of code I try to print line banking app, so banking app.purchase, and the username is Daniel, the item is, let's say, iPhone 12, and the merchant name is Rock the JVM Store, and the cost is, say, $3,000, which is a lot of money, then this guy will block until all these futures are completed, and it will print our transaction success status. So if I right-click and run this, no matter how long it takes, this will still block until the futures are completed. So, waiting on the future, meaning of life 42, mark poking bill, and success, which is the status of our transaction. So notice that we didn't really need to add the sleeping calls in the main thread because this call will block until all the futures are completed. Now, I generally recommend that you use asynchronous computations with futures and functional operators on them as much as possible, but in the rare situations that you do need to block until a future is complete, use await.result, pass it the future that you want to wait for, and the duration written like this. Also, await.ready achieves almost the same result, but it returns, instead of the result within, it returns the same future as ready. Now, the await.result and await.ready operate on the principle that if the duration here has passed, this will throw an exception with a timeout. So this is how we block on a future if we need to. Now, the next topic that I want to talk about is manual manipulation of futures with promises. Now, before I go into that, notice how starting from the beginning of this lesson a couple of videos ago, suddenly we don't need vars and mutable containers anymore, so this is pretty cool. This is definitely a step in the right direction. Futures are the functional way of composing non-blocking computations, which we'll return at some point. However, notice that we can only read or manipulate the results from futures either by calling onComplete as we saw earlier, or better by using functional composition like map, flat map filter, and all these kinds of fallback methods like recover and all that kind of stuff. So in a sense, futures are read-only when they're done, but sometimes we need to specifically set or complete a future at a point of our choosing, which is the need that introduces the concept of promises. So the pattern goes like this. I want you to watch me as I'm writing this. So I'm going to create a thing called a promise as a promise of int. I'm going to need to import the promise class and just instantiate it like this. So this calls the apply method for the promise companion object. Now I want you to think of a promise as some sort of a controller over a future. In particular, the promise has a member called future, which it holds and manages. So I'm going to attribute that to a value called future. So the future is under the hold or under the management of this promise. So here's what I'm about to write. I'm going to write a small producer-consumer implementation using futures and promises. And the pattern goes like this. In thread number 1, which is the consumer basically knows how to handle the future's completion. So it says future on complete, and I'm going to pass in a case success with some result. And let's say I just print this out. So print line, I'm going to say consumer, I have received the value denoted by R. Okay, so this is thread 1. The consumer knows how to handle the future. Thread number 2 is the producer, and goes like this. I'm going to say val producer equals new thread, which is going to do the following. So in a separate thread or in some kind of distributed fashion, I'm using a thread here for simplicity. Let's say this prints or logs the producer crunching numbers or something like that. So producer crunching numbers. All right. And I'm also going to simulate a long computation by saying thread sleep. And I'm going to sleep for a second. And here's the critical part. This is fulfilling the promise by saying promise dot success, and we're just going to pass in a value, say 42, which we all know is the meaning of life. All right, and after that I'm going to just print line consumer done, or producer done. This is the producer. All right, so this part is the critical part. It basically manipulates the internal future to complete with a successful value 42, which is then handled in onComplete by some consumer. All right, so this is the promise pattern. One thread knows how to handle the future, and one thread inserts values or inserts a failure into the future by calling promise.success. Or alternatively, if you want to fail, you can say promise.failure with an exception. All right. But in our simple case, we're just going to produce the value 42. And if I add a thread sleep here, just to make sure that everything has the chance to run, so let's reduce the sleeping time to half a second because we're waiting too long. And thread sleep for 1 second here on the main thread in the JVM. Then, if I call producer.start, then I should be seeing producer crunching numbers, waiting, and then at the time the producer is done, the onComplete callback should trigger. So let's see it in action. So running this, none, waiting on the future, the meaning of life is 42, mark poking bill, success, and ta-da! We see the crunching numbers, and at the moment the producer is done, the consumer is automatically triggered. So see how suddenly the producer-consumer problem is so much simpler now, as we don't have any concurrency issues. Now, the future promise paradigm is more powerful as it separates the concern of reading or of handling futures and of writing to a promise, while eliminating concurrency issues almost completely, as it gives you almost complete control over when and how you want to set a value to a future when you see fit. Alright, so we've learned quite a lot in this lesson. We have learned in this particular video how to block on futures and how to manipulate them with promises. Let's get back to the next video where I want you to solve a few small exercises to practice your skills with asynchronous functional programming with futures.